in 3.2, we got introduced, or reintroduced for a lot of us, into logs. You're learning how to simplify the logs. You're learning how to graph logs, how to convert from log to exponential or vice versa. And then also how to deal with ln, which was at the end of the notes from 3.2's lesson. So the first one just says to evaluate the log. And remember, you have options here. If you can do this mental math-wise, then you can go straight to the answer. If you can't see what power you'd have to raise 6 to get to 36, then I can set this equal to x. I can convert it into exponential, which means the 6 goes over, picks up the x, and then drops off the log, leaving just the 36. And then you can use your change of base property. You can just put it right on my desk. Thank you. Change of base property to say what power would I raise 6 to get to 36. The answer there would be what? 2. And then the bases are the same, so x is 2. Because we introduced the x, my answer is not really x equals 2. It's just 2, which is the same thing that you could get by just looking at log base 6 of 36 and asking yourself what number would you need to raise 6 to get to 36. So again, sometimes there's no actual work required, but you have to be really careful on those because that means that there'd also be no partial credit given if you write the wrong thing. Questions on that one? All right, number 2 says to rewrite the expression. So the first thing I'm going to do is rewrite it in terms of, if it's ln, it's really what? Log base e of 1 over e to the 5th. Now I want to see if I can simplify this. So what can I do with 1 over e to the 5th? Janet?
E to the negative.
Good. I can bring this to the numerator, and in doing so, it becomes e to the negative 5th. And then also in 3.2, we talked about properties of log e or ln of e, right? What happens when the base here is the same as the base here? They cancel out, leaving you with the exponent. So I would get 2 times negative 5, which is negative 10. Okay, then came the graphing. So it says identify the domain, the range, the asymptote, and the y-intercept, and then graph the function. So I want to start by taking my function that's there and rewriting it in exponential form. So if this is y equals log base 5 of x plus 4, then in exponential form it's 5 to the y equals, this goes away, x plus 4, and 5 to the y minus 4 equals x. Now I've solved it for x, and I can plug in my points. Wait for it. All right, so if I use the t-chart, this time when I'm using logs, what am I plugging in for? The y. So this becomes negative 1, 0, 1, and then I'm going to plug them. This is 1/5 minus 4, which is negative 3 4/5. This is 1 minus 4, which is negative 3. And this is 5 minus 4, which is 1. Okay, so now I can plot those points. Negative 3 4/5 and negative 1. Negative 3 and 0, and then 1 and 1. From my initial equation, I should also be able to identify my asymptote, right? If there's x plus 4 inside the parentheses there, what's my vertical asymptote? X equals negative 4. So then I know my graph does this. What's the domain of my function? Negative 4 to positive infinity. Does the negative 4 get a bracket or a parentheses? Parentheses. And it said, what's the y-intercept? That comes from the middle of my t-chart, which is negative 3, 0. So on Wednesday's quiz, you will again have your scientific calculator, but these things are going to need to be kept exact. So there's no rounding. There's no using the calculator to figure out what 5 to whatever it is, get a decimal and do that. You're not going to do that. The only ones that you're going to use, it will actually tell you to round on, are the ones involving e's or ln's that you have to round, or the change of base, which we're going to learn today. Everything else, or the money, everything else is going to say keep your answers exact. Okay, so you want to keep that in mind, that you don't want to be letting the calculator do the work on the exponents for you. You need to make sure that you're comfortable doing that part. Ian?
Isn't that the x-intercept?
Oh, yeah, sorry, this should be x-intercept. The y-intercept, this time you can find, but sometimes you can't. So the logs will say x-intercept, the exponential will say y. Yep.
When you have an exponential, you always look for the horizontal asymptote, and then with the log, you look for vertical.
Exactly.
So like, a log can have a horizontal asymptote.
It cannot. No. Because it's always going to be increasing, right? There's no stop.
Okay.
Yeah. Gia.
So would you make us find the y?
No. So on your exponential functions, which is what we did, like f of x equals 3 to the x, something like that, those questions are going to be different, God bless you, than the log, which is f of x equals log, like something like 3 to the x, right? So on the exponential, there's a horizontal asymptote, and it goes with your vertical shift. I think I asked domain and range for both. Domain is going to be negative infinity to positive infinity. Range is going to be 0 to positive infinity and also gets affected by your vertical shift. And then I'll ask for the y-intercept here because we plug in 0 for x. It, again, should be in your t-chart. The log function, you'll have a vertical asymptote, and that comes from the x equals whatever's inside the parentheses. Your domain is now restricted. It's 0 to positive infinity, and it shifts with the horizontal shift, or whatever in the parentheses. So that affects both of these. Your range this time is all real numbers, and it will ask you for your x-intercept, which you're plugging in for y, so it should be easy. It should already be in your t-chart. And remember that an e function, if the base is e, it follows the same as an exponential. And if the log is ln, it follows the log. Okay, e is just like saying the base is 2.7, and ln is just like saying log of 2.7. All right, so here's some homework questions. This one said, use the properties of logs to simplify the expression. This is 1/8 times log base 8 to the 64. So the first thing I'm looking for is what power do I have to raise 8 to get to 64, which is what? Squared. And then I get 1/8 times 2, which is 1/4. So today we're even going to know like one more step to doing this if you want to do it that way. We're going to talk about more properties of logs, but for last night's stuff or for 3-2, that's how you would do it. This one says use the properties of natural logs to rewrite the expression. So this time I've got ln of 1 over e to the 6th. I'm going to bring e to the 6th to the top, and in doing so it makes my exponent negative 6. And then we talked about that you could either cancel these out, keep the negative 6, or make that log base e of e to the negative 6. And this would be 1, and then the exponent is what you save, which is negative 6. And again, today we're going to talk about properties of expansion and condensing, and actually you can look at them in a different way. This one said find the domain, the vertical asymptote, the x-intercept, the log function, and then you had to graph this one. Notice it said sketch by hand. I also warned you last week. I put it in the instruction on the assignment. You have to be graphing these by hand. So if you're losing points on the homework because you're not showing me the work of the graphing by hand, you're just picking it multiple choice, realize that that's why that's happening. Okay, I've been saying it over and over and over again. You won't have a multiple choice test. You won't have a multiple choice quiz. You need to know how to graph these by hand. You need to be showing the work. Some of you on these homeworks are taking like hundreds of minutes, which I'm assuming you leave it open and you just go back and forth. And then some of you are taking 3. So realize that when you're a person that's taking 3 minutes to do homework, you are flagging yourself, and I'm looking at your stuff very, very closely. This says find the domain, the vertical asymptote, the x-intercept of the log function, and then enter your domain using interval notation. Y equals 1 minus log base 5 of x. So the first thing I'm going to do is I'm going to take this log and I'm going to rewrite it in exponential. So I get y equals 1 minus log base 5 of x. Before I can convert it to exponential, the log has to be the only thing on the side by itself, which means I need to subtract the 1 from both sides. So I get y minus 1 equals negative log base 5 of x, and that's still not by itself. I got to get rid of the negative. So I can multiply everything by -1. Negative y plus 1 equals log base 5 of x. And now I can convert it into exponential. The 5 is going to come over and pick this up. So it would be 5. I can rewrite it as 1 minus y, or I could keep it as negative y plus 1. It doesn't matter. Equals, now I've got x on this side. Now comes my t-chart. And again, this is a log, so I'm plugging in for y. I would do 5, 1 minus a -1, 5, 1 minus 0, and 5, 1 minus 1. So this becomes 5 squared, or 25. This becomes 5 to the first, or 5, and this becomes 5 to the 0, or 1. So when I go to plot my curve, -25, -1 is there, 5, 0 is there, 1, 1 is here. And because we know the transformation says that this is up 1 and upside down, and I have a vertical asymptote at x equals 0 because there's nothing in there, I should know my graph looks like that. It's flipped upside down. So domain is 0 to positive infinity because there's nothing adding or subtracting inside the parentheses. The vertical asymptote is x equals 0, same reason. And then the y-intercept comes from the middle of my t-chart, which is 5, 0. And then your graph would look like that.
So what's your asymptote?
X equals 0.
Okay, so if you don't know, like it's always 0?
If there's no horizontal shift, then it's 0. So whatever's being inside the parentheses. And I said it last week, but I'm going to say it again. Your homework gives you the x equals. You need to know to put the x equals. If you don't put the x equals, then you're losing points for silly things like that. This is an asymptote. An asymptote is a line. The line has to have the x equals for the logs, the y equals for the exponentials. Okay. Questions on that one? So obviously these are going to be worth more points than the other ones because these have a lot more steps. Keep that in mind. So it says find domain, vertical asymptote, x-intercept of the log function, and then obviously this one had a multiple choice to graph it, but we're going to graph it by hand. So to get domain, I'm going to look and see if there's anything inside parentheses. There's not, which means it's going to start at 0 and it's going to go to positive infinity, and my vertical asymptote is x equals 0, which again must be x equals. Then I'm going to put this into exponential notation or exponential form. Before I can move the 2 to pick up the y, log's got to be the only thing on that side by itself. So I'm going to go y minus 1 equals negative log base 2 of x. And then I'm going to multiply everything by -1 because, again, it can't be a negative log. So negative y plus 1 equals log base 2 of x. Now I'm going to convert it into exponential. So 2 goes over and picks up the negative y plus 1. Drops off, leaving you with the x. And then I'm going to plug in for the y. So I get 2, negative 1 is 1 plus 1. That's 2 to the second, which is 4. 2, negative 0 plus 1, which is 2 to the first, or 2. 2, negative 1 plus 1, 2 to the 0, which is 1. And then you would plot your points. So 4, 1, 2, 3, 4, negative 1, 2, 0, 1, 1. My vertical asymptote is at x equals 0, and my curve looks like that. If you look at it based on transformations, it's upside down because the negative on the front of the log, and it's up 1, which is consistent with what you found. Questions on that one? So some of you have been losing points on your graphing for your homework. I said it over and over again, and it's in the directions on the assignment. For these questions, I know they're multiple choice. I know the answer's there. No quiz or test you get from me is going to be that way. You need to be showing the work for your t-chart and your graphs and then selecting your graph, okay? Don't lose points on homework because you're being lazy. All right, this one says write the log equation in exponential form. For example, exponential form of ln 5 equals 1.6, blah, 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 blah. So the first thing I'm going to do is change this so that it is log base e of e to the second equals 2. And then I'm going to convert this into exponential. E comes over and picks up the 2. E to the second would equal e to the second And that's where this, it should have been e to the second equals e to the second. Yeah, this should have equaled that. This would have been your exponential form. Questions on that one? So 3.3 continues with properties of logs. And then again, remember we're doing 3.4. Like we're going to stop here for a quiz. We're going to do one more section and that's what your test will be. So 3.3 is properties of logs. Today we're going to talk about change of base, which is something you can do when the log base is not 10. And we're going to talk about expanding and condensing logs. So we start with change of base. We've been saying that the log button on your calculator is log base 10. So what do you do when the base on your log is not 10? This is what you use. It's called change of base. And so you take your log, whatever the base is and whatever the larger number is, you put the one that is in the larger space, not necessarily the larger number. That log of that goes in the top, log of the base goes in the bottom. Again, think base, bottom, okay? It's going to go in the bottom. Because this is any log, you can make any log equation ratio using any base. And we have calculators that use base 10. We use base 10. Or the natural log would be log base e. So if I have log base 3 of 23, then I'm going to do log of 23 in the top, log of 3 in the bottom, or ln of 23 in the top, ln of 3 in the bottom, and then literally divide ln of 23 by ln of 3, and you should get 2.85. So this is your common log. When it says to write it as a ratio of common logs, that's log base 10. And when it says to write it as a ratio of natural logs, that's your ln.
Would it be because they cancel out?
No, they don't really cancel out, but if you wanted to convert it into exponential, they would eventually simplify to give you something like that. But it's just you're setting up a ratio. You're finding the log of both parts of it, which ends up working out. Some of the graphing calculators actually allow you to change the base, but again, you won't have a graphing calculator for this. So you want to make sure you know how to set it up this way. All right, so this says rewrite the log as a ratio of A, common logs, B, natural logs. Then use the calculator to evaluate the log and round to 3 decimal places. So the common logs are your log base 10. What number goes in the top? What number goes in the bottom? 5 at the top. So this is log of 5 over log of 8. And then common logs would be ln of 5 over ln of 8. And then it doesn't matter which one you use. They should give you the same answer. Be careful where you put your parentheses if you're going to do it all in one step. So if you do ln of 5, you have to make sure you close the parentheses, then hit divided by, and then hit ln of 8. You should get 0.7739 or 0.774. So you can use one method to check the other because they should both give you the same answer. So a log of 5 divided by log of 8 should give you the same answer as ln of 5 divided by ln of 8. Questions? All right, properties of logs. So we are going to learn how to expand, and then we're going to learn how to condense. The first property is the product property, okay, which says if I am finding the log of a product, so this is a product, right, two things being multiplied together, then I can actually separate that out by making it an addition problem. Because think about what's happening. These are all exponentials, right? So if I have an exponential function and I want to take two numbers like x to the third times x to the fourth, what do I do with those exponents? When the base is the same, you add them. So it's the same thing. You're going from multiplication to adding, okay? The quotient property is division, and it says if I have a single log of a quotient, like u divided by v, then when I expand it, I'm going to subtract it, because if I had x to the 7th over x to the 5th, I would subtract those exponents. And then the last one is the power property, which is raising a power to a power. When you're raising a base or a number to a power, then it becomes multiplication. I can actually push this to the front of the log and multiply times whatever's on the exponent. Because again, if I was raising something like x to the third to the fourth, or raising a power to a power, what do you do with those exponents? Multiply, okay? So multiply, like when you have a product and you split it, it's addition. When you have a division problem and you split it, it's subtraction. When you have a power being raised, when you split it or you bump it to the front, it becomes multiplication. All right, this one says approximate the log using properties of logs, given that log base b of 2 equals 0.3562 and log base b of 3 is 0.5646. So I need to figure out how to rewrite these in terms of a product, a power, or a quotient, right? Using log base b of 2 and log base b of 3. So can I rewrite 6 in terms of 2 and 3? How? 6 is the same thing as what? 2 times 3. So I can rewrite this as log base b of 2 times 3. And then what did we just say happens if I expand and it started multiplication? Becomes addition. So they both get the log base b. And then it's already telling me log base 2 is 0.3562 and log base b is 0.5646. So then I can just add them. And you get 0.9208. Okay, now look at b. It says log base b of 3 times b to the negative 3. So there's a couple ways to look at this, but one is what happens when you raise a product to a power. What would I do with that power? If you want, you can bump it to the front. So if I'm pushing this to the front, then this is negative 3 log base b of 3b. Now I've still got the log of a product. So how do I split a product? Addition, good. So I can keep this like this. Or I can distribute the negative 3 onto each one. It doesn't matter. Because that negative 3 is part of both of those. So now we're given what log base b of 3 is, 0.5646. What about log base b of b? It's 1. If the base and the top are the same, right? It's 1. So now I get negative 3 times 1.5646. And I get negative 4.6938. At this point, I'm not very confident in my math skills. I think that's right. So you would have gotten the same thing had you distributed this here and rewritten it as negative 3 log base b of 3 plus a negative 3 times log base b of b. And then I would have multiplied this out. And this would be 1, and this would be minus 3. So you'd get the same answer either way. And these properties can be applied in all different orders. Questions?
Where'd you get the 0.5?
In the directions, it told me log base b of 3 was 0.5646. There'd be no other way to get that, right? Because there's no such thing as log base b. Like, that's not a number. It would have to give you that number to substitute it in. Questions so far? All right. Now it says use the product rule to expand each log expression. So if I look at A, I've got log base 3 of 9 times 5. How do I expand when it's multiplication? Addition. This becomes log base 3 of 9 plus log base 3 of 5. Is there something there that can be reduced or simplified? Is there a number I can raise 3 to get to 9? 2. Is there a number I can raise 3 to get to 5? No. So it will stay as 2 plus log base 3 of 5. Okay, B, log of 1,000 times x becomes log of 1,000 plus log of x. What's the base on log? 10. Is there something I can raise 10 to get to 1,000? 3. Is there something I can raise 10 to get to x? Nope, it's going to stay that way. C, log base 5 of 25 over x. Now I've got a quotient. When I split this, it becomes what? Subtraction. So this is log base 5 of 25 minus log base 5 of x. Is there something there that can be simplified? What?
2.
Good. Log base 5 of 25 is 2 minus log base 5 of x. D, ln e to the third over 8. So you've got a product, you've got a power and a quotient. I can separate this out, e to the third minus ln of 8. And then what can I do with ln of e to the third? I could change it so it's log base e of e to the third. Then what? This actually cancels and leaves me with just 3. If you think about it the other way, if that 3 bumps to the front, this is 3 ln of e minus ln of 8. ln of e is log base e of e. And that becomes 3 times 1, or 3, minus ln of 8. Same answer either way. So all of these rules apply the same answer, end up with the same answer. So you can bump a power forward. You can simplify it by doing ln of e, okay, and taking the exponent, anything like that. So you always, the simplest form of log base e is ln. So if it says simplify and you have log base e, you want to rewrite it as log n. As ln. So for the first one, the 2 gets bumped to the front. It's 2 log base 5 of 7. There's nothing I can raise 5 to get to 7, so it stays that way. For the second one, the 4 gets bumped to the front, so it's 4 log base 2 of 8 times x, which becomes 4 log base 2 of 8 plus 4 log base 2 of x. Make sure both of those terms get the 4. If these parentheses were not here and the x was only, or the exponent was only on the x, then the x term of your log would only get the 4. But because those parentheses are here, both of the terms get the 4. Then you get log base 2 of 8, and 2 to the third power is 8, so that can be reduced. And then 4 times 3 would be 12. 12 plus 4 log base 2 of x is as simple as it goes. C, your exponent, if you're raising it to a square, if you're square rooting, is really a half. And then the exponent should get bumped to the front, so that should be a half log base x, or log base 10 of x. And then the last one, again, they both have the fifth, so the 5 gets bumped to the front of both. It'd be 5 ln of 6 plus 5 ln of e. Ln of e you cancel, keeping just the exponent, which in that case is a 1. 5 times 1 is 5, and so it should be 5 ln of 6 plus 5. Questions on any of those? All right, so same thing. It says use log properties to expand the expression as much as possible. So I'm going to expand. This 2 goes to the front, so it's 2 log base b of x square root z, which becomes 2 log base b of x plus 2 log base z raised to the 1/2. Now what happens to that exponent? Goes to the front. 1/2 times 2 is 2 log base b of x plus log base b of z. What's the b?
You couldn't keep it as a square root.
Nope. A square root is just like an exponent, and an exponent can't be there when we expand. Okay, next one is a power and a quotient. So the 3 goes on the front. 25 over y. This becomes 3 log base 5 of 25 minus 3 log base 5 of y. Log base 5 of 25 is 2. So this becomes 3 times 2 minus 3 log base 5 of y, or 6 minus 3 log base 5 of y. C, ln of 10 over e becomes ln of 10 minus ln of e. And what is ln of e? 1. So this is ln of 10 minus 1. And log 9 plus log square root 10 becomes log 9 plus log 10 to the 1/2, which has actually a couple ways to do it. One is I could figure out that 10 to what power is going to give me 10 to the 1/2, and I could cancel it now. Or I could rewrite it as 1/2 log 10, and log base 10 is 1. This should be 9. So that's 1/2 times 1, or 1/2. So there's not always just one way to do them. Be careful, okay? You could have, like, if you look at C and you go back to how we started today's lesson, you could have brought e to the top as an e to the -1, and then I could have simplified it that way. So just be careful. There's sometimes more than one way to do these. And again, when you're practicing change of base tonight with your homework, please make sure you're using a scientific calculator. That's what you're going to need on your quiz. So this is condensing. Now we're working the other direction. Notice that on the left-hand side of the equal sign, you have more than one logs. They have to have the same base, and then we can condense them. If it's addition, it becomes multiplication. If it's subtraction, it becomes division. And if it's a number on the front, it becomes the exponent on the larger number. So this is the reverse of what we did before. What we did before was expand, and now we're condensing. Same properties though. So this says write as a single log. And again, this time it says to condense, but eventually it's just going to say expand or condense. You got to figure out which one to do. If you look at A, as soon as you see that there's 2 logs, you should know you've got to condense it down to 1 log. This is addition, which means when I rewrite it, it's going to be multiplication. Now this doesn't say to simplify. If it had said to simplify, you could simplify before you did that. But for right now, we're just going to condense. B, they are both log base 10. Now it's a minus, which means this is division. The 6x goes in the top, the 6 goes in the bottom. Again, if it said simplify, I could go further with that, but I'm going to leave it the way it is for now. See, the 2 comes to the back of the 9. So this is log base 3 of 9 squared minus log base 3 of 27. And that becomes log base 3 of 9 squared over 27. Again, I'm just going to leave it, but if it did say simplify, I would keep going. And then the last one is ln of x minus 2 plus 5 ln of x. So the 5 is going to become the exponent on the x. I'd get ln of x minus 2 plus ln of x to the 5th. And I'd get ln x minus 2 over x to the 5th.
Why is it over multiplication?
Oh, sorry, I just thought it's totally wrong. It should be times x minus 2 x to the 5th. And that order doesn't matter. You can put x to the 5th on the front if you want to. Questions on those? Okay, last one just has multiple parts. So use the properties of logs to expand each expression where possible, evaluate without a calculator. So in the top, you've got just one number, but in the bottom, you've got separate, okay? The rule is if it's in the bottom, it gets a minus. If it's in the top, it gets a plus. So this would be log 9 of 81. That's going to stay positive because that's my numerator. Minus log 9 of x squared minus log y to the 3rd. Now we're expanding, which means anything that's got an exponent needs to get bumped to the front.
Why did you not give the 9 to the y to the third?
It should be there. There. So now it's log 981 minus 2 log 9 of x minus 3 log 9 of y. Any of that get simplified? 9 to what power is 81? 2. So this is 2 minus 2 log base 9 of x minus 3 log base 9 of y. So think about this in reverse. If I was taking this, well, first of all, let's say I was taking this and I was condensing it. Anything with a minus sign is the denominator. Anything with a positive is the numerator. So if I had something that said, this is like the biggest mistake people make. Let's say it says negative log 3 of x plus log 3 of y minus log 3 of z. What of that condensing is going in my numerator?
1.
Just the y. What of that is going in my denominator? The x and the z. So if I rewrote this, this would be log base 3 of y over x z. Everything that's negative goes denominator. Everything that's positive goes numerator. Because you could rewrite this in any order. It shouldn't impact your condensing. So be really careful with the signs.